Hello, my chemistry friends, and welcome to lesson 2 of online remote learning. Before we get started, I want to show you what's going to be happening over the next couple of days in this unit. Today we are looking at mole ratios. We just finished balancing equations. On Friday, I'm going to have a short lesson for everybody up, but it's going to be a targeted review. And we will also be doing a vocab quiz. I will post the vocab words with this assignment so that you know what you need to study. And then most of the review is going to be Regents questions to help you prepare for your Unit 6 test, which will happen next week on Monday or Tuesday, depending on which class you are in. Still trying to figure out how tests are going to work, but I'm going to guess it's going to be through Castle Learning on a locked mode, meaning they're not going to give you your hints and things like that. But look out for more information. I've posted your unit review sheet and everything along with this assignment, okay? So today we are doing our warm-up. Hopefully you've already done it. We're going to go through our Edpuzzle and learn about mole ratios. Your work today is going to be a worksheet doing mole ratio problems along with conservation of mass problems that we did before remote learning started, and then you'll end class with an exit ticket. Today's learning target: I can use mole ratios from a balanced chemical equation to predict the amount of reactants and products needed in a specific reaction. So we balanced the equation to figure out how many moles of this we need to make how many moles of that. But what if I want to make twice as much? What if I want to make half as much? That's what we're going to be doing today. There was a request to go through the types of reactions one more time very quickly. We spent a little bit of time doing synthesis and decomposition before remote learning started. Synthesis, you should remember, has two things before the arrow and one product at the end. Decomposition is the opposite. You start with one reactant and break it apart into its two different parts. Single and double replacement, you'll notice you'll have two reactants and two products. The difference being, in a single replacement reaction, you have a single element reacting with a compound to get a new compound and a new single element. So if you ever have a pure element by itself before and after, you'll have a single replacement reaction. Whereas double replacement, you have the two compounds here and everybody's switching places. So I'm going to give you some time to practice. I'm going to post 3 equations on the screen. I'd like you to tell me what type of reaction each one of them is. The first one, we have two things making one. That is a synthesis. The second one, we have an element reacting with a compound to produce a compound and an element. That single element is your hint that it is a single replacement. Here, two compounds, everybody switching places is a double replacement. Okay, I didn't put decomposition. It would be just like this going backwards, where you have one thing breaking apart. But we've done a lot of that one, so I didn't feel we needed to practice. But I do have a bonus question. One of these equations is not balanced correctly. Which one of these equations is not balanced correctly? Hopefully you chose this second one with the single replacement with lithium, calcium, and bromine. If you look carefully, lithium, I start with 1 here, but this coefficient means that I have 2 in my products, meaning that I also need a number 2 here at the beginning. 2 lithiums, 1 calcium, 2 bromines, and 2 bromines. Okay, if you want help practicing balancing equations, there will be some more on your classwork today, and it's definitely something that you can come and I can just make up problems for in office hours. Okay, but now let's talk about mole ratios. Before we do that, I'm going to give you a real world example where it's basically the same type of problem, except you're using a chemical equation in place of a recipe. So our recipe today, let's say we're making a grilled cheese sandwich. If I want to make a very basic grilled cheese sandwich, your recipe will call for 2 pieces of bread and 1 piece of cheese. If you put those together, you will get 1 grilled cheese sandwich. So let's turn this into a chemical equation. 2 pieces of bread, 1 piece of cheese, 1 grilled cheese, which I have made the compound B2C for my 2 breads and my 1 cheese. But let's say we're stuck at home, we're really bored, we don't know what to do, and so we're really hungry. And so what if instead of making 1 grilled cheese sandwich, you wanted to make 4 grilled cheese sandwiches? Is 2 pieces of bread and 1 piece of cheese going to cut it? Hopefully you said no, because for every additional sandwich you want, you have to add more ingredients. So if I wanted 2 grilled cheese sandwiches, I'd have to double my reactants. And because I want 4, I need to quadruple my reactants. So to get my 4 grilled cheese sandwiches, I'm going to take my 2 pieces of bread multiplied by 4 to get 8, 4 pieces of cheese, and I'll get my 4 grilled cheese sandwich. That's the same thing we're going to be doing with mole ratios, except instead of grilled cheese, they're going to have some compounds, okay? One quick note, when we're doing mole ratios, just like grilled cheese sandwiches, they don't necessarily have to be whole numbers. Let's say your little cousin's really hungry and they want half of a grilled cheese sandwich. Luckily for you, you get to save some of your precious bread and cheese, because to make half a grilled cheese sandwich, how much bread will we need? How much cheese will we need? Half of everything. Okay, so now for every 1 piece of bread, we only need half a piece of cheese, and we'll get half a grilled cheese sandwich. This is still showing conservation, it's just we're tweaking the ratio to the recipe we want to follow. Okay, so now let's throw in a chemical equation. I have a synthesis reaction for water. Who can tell me how I know this is a synthesis reaction? Good, it is a synthesis reaction because we have 2 things coming together to make 1. Now, what will the ratios be when this is a balanced equation? Because I have 2 hydrogens at the beginning, 2 hydrogens at the end, we can ignore those for now and deal with the oxygens, where I have 2 oxygens at the beginning and only 1 at the end. I'm going to fix that by putting the number 2 in the front. That doubles my waters. But it didn't only double my oxygen, it also doubled my hydrogens. So now I need to go back to the beginning and double my hydrogens as well. This is a balanced equation. 4 hydrogen, 2 oxygen, 4 hydrogen, 2 oxygen. You can also put a number 1 there to finish it. Moving forward, we are going to take this and translate it to words, and it will make the next process a little bit simpler. For every 2 moles of hydrogen, we need 1 mole of oxygen. These numbers in the front tell you the moles, and we will get 2 moles of water. But let's say, just like you were hungry with your grilled cheese sandwiches, what if I want to tweak the recipe? How many moles of water will be produced if 10 moles of hydrogen reacts with excess oxygen? Excess oxygen means you have more than enough. You have an unlimited supply, so you don't need to worry about it. Okay, I'm going to walk you through this one. The next one you'll be able to answer yourself. So the first thing you want to do is, in a mole ratio, you're only ever talking about 2 substances, one known and one unknown. In this question, they're asking us how many moles of water if we know how many moles of hydrogen are reacting. I don't care about the oxygen. Mole ratios, you only ever care about 2 things, and that's very important. And so what I like to do, and what the Regents will ask you to do when they say show a correct numerical setup, is they want you to set up a proportion, knowing that for every 2 moles of hydrogen, you get 2 moles of water. That is the molar ratio between hydrogen and water. Now, some of you may already see the answer, but in case you don't, I'm going to keep going with the math. You're going to set this equal to the proportion in the real world problem, meaning we don't have 2 moles of hydrogen, we have 10 moles of hydrogen, and we're trying to figure out how many moles of water. From here, you cross multiply. 2 times x equals 2 times 10, which gives us 2x equals 20. Final answer is 10 moles of hydrogen. Now you can also ask yourself, does this make sense? For every 2 moles of hydrogen, I get 2 moles of water. That is a 2 to 2 or a 1 to 1 ratio. So if I start with 10 moles of hydrogen, I'm going to get the same number of moles of water. It's not always a 1 to 1 ratio, of course, because let's say a question asks you about oxygen, which, surprise, surprise, your next question does. So still having the same reaction, how many moles of oxygen are needed to completely react with 1.5 moles of hydrogen? So this time, we care about oxygen and hydrogen. Who cares about the water at the end? It doesn't matter. We only care about the reactants. So the first step, what is the mole ratio of hydrogen to oxygen? For every 2 moles of hydrogen, you get 1 mole of oxygen. That is your first ratio. We are going to set this equal to what they're asking us about in the problem, making sure our units stay in the same place. 1.5 moles of hydrogen, X moles of oxygen. Cross multiply, the answer is 0.75 moles of oxygen. Okay, and that's really all there is to do with mole ratios. They may try to confuse you by throwing in an extra number here or there. They do also look very similar to different types of problems we answered. So I'm going to give you a couple more hints on how to do this. But first I want to go through an example of what a multiple choice question would look like for this. Which of the following is the correct mole ratio of iron to oxygen in the synthesis of iron 3 oxide? So they'll give you the balanced equation and they'll give you some answer choices. Which one of these, A, B, or C, is the correct mole ratio of iron to oxygen in the synthesis of iron 3 oxide? Hopefully you did not choose answer choice number 1 because this is not the correct mole ratio. We are looking at moles of iron to oxygen, which is a 4:3 ratio. You use the numbers in the front. Hopefully you were able to eliminate the second choice because the mole ratio has nothing to do with grams. You are just talking about moles. This is a word for word a Regents question, and so they want you to look closely at the numbers and the units, okay? All right, so now let's jump into an actual question. I'm going to give you a chance to try it on your own now and then put your answer in the Edpuzzle. This is not graded, I just want you to try it, and then I'll go through the work. Using the balanced equation above, how many moles of chlorine are needed to make 8.2 moles of sodium chloride? I know that for every 2 moles of sodium, I get 1 mole of chlorine to make 2 moles of sodium chloride. So the first thing, we have chlorine and sodium chloride. That is a 1:2 ratio. So I'm going to set that up first here. For every 2 moles of sodium chloride, I get 1 mole of chlorine. I know in the problem I have 8.4 moles of sodium chloride, and I'm trying to find the moles of chlorine. Cross multiply, you should have put 4.1 moles of chlorine. Now, if you flipped this ratio and you had chlorine on top and sodium chloride on the bottom, as long as you did the same here where you put your problem numbers, you will still get the same answer. The main thing is you keep the numerator units consistent and the denominator units consistent as well. Okay? So now I'm going to throw in a different type of problem that you've already learned how to do, but that can often lead to some confusion as to which one is which. So we're still going to use the same equation. This was actually on your warm-up from our last lesson, and let's see if we can figure it out. This question asks if 92 grams of sodium reacts with chlorine to produce 233 grams of salt, how many grams of chlorine reacted? Now you'll notice this question does not have the word mole in it anywhere. They in fact give you the grams of sodium chloride, and they want to find the grams of chlorine. If they give you every single value except one, you get to use the law of conservation of mass, which is the mass of the reactants equals the mass of the products. So for this type of problem, all you need to do is set up an algebraic expression and solve for x. Okay, 233 minus 92 gives you 141 grams of chlorine. This is important because they will often give you these types of questions and it's easy to mix them up with mole ratios. You will know you are using a mole ratio if the question asks you about moles. If you were doing that, that's when you use the coefficients from the balanced equation and you set up a proportion like we did. If you are doing conservation of mass, there is no word of moles or anything like that. You do not use the molar ratios at the beginning. Those numbers do not apply. Those numbers are just going to be there for mole ratios. And so then you just solve for x like we did. Okay? I'm going to post some questions that will be your graded questions. Please make sure you have paper and calculators to walk through these problems before you submit your answers. The next 4 questions will be graded. All right, so your balanced equation is 4 moles of lithium bromide react with 1 mole of diatomic oxygen to produce 2 moles of lithium oxide and 2 moles of diatomic bromine. These 4 questions will be the ones that are on your Edpuzzle. Please take your time, they will be graded. Use a calculator, use some pen and paper, take your time and do your best. So this is where you should be with your agenda. Warm-up's done, just finish your Edpuzzle. Ooh, ooh. You're going to have a classwork worksheet that's posted on Google Classroom. This is going to be due before our lesson on Friday. So please take your time to do it. If you're in the Tuesday, Thursday class, please just get it done before the weekend. As a reminder, we will be having a vocab quiz on on Friday. The words will be posted on this assignment on Google Classroom, and our Unit 6 test will be next week at the beginning of the week. I will be on office hours for the rest of the week from 11 to 2 p.m. You can use the link that's on the syllabus or that was posted on Google Classroom. Okay. Thank you all. Have a great day.